Hi everyone, Unit 4 Applications of Derivatives, Subsection 2 Applications to Physics. So there's your learner outcomes. We're going to be dealing with velocity, instantaneous velocity, max-min velocity, max-min height, accelerations. We're going to use our concepts of derivatives and the second derivative for finding out velocities and accelerations given the displacement functions, that kind of stuff. We're going to be dealing with derivatives around all types of concepts in physics. We're going to start off with distance is velocity times time, but then move on to velocity and accelerations. So all good. And yeah, so part 1, maximum and minimum distance and time problems. So these ones are much more physicsy than the last section. The derivatives get a little more complex, and there's shortcuts that we can use, but I'll have to explain to you when we can use them and when not to. So, example 1. An airplane flying west at 200 kilometers an hour passes a house 10 minutes before another plane flying south at 300 kilometers an hour passes over the same point. Assuming that both planes are at the same altitude, at what time is the distance between them a minimum? What is that distance? Round your answer to the nearest hundredth. Okay? So, rounding to the nearest hundredth is nice because then we can use our calculator and decimals and that kind of stuff. But, alright. So, let's talk about this, how we get the solution here. Because we want to have at what time is the distance between them a minimum, okay, I'm trying to minimize the distance. So that means I need a distance equation or distance function. Okay, so we're going to describe the position of the planes in respect to the house at any time t after the first airplane flies over. So if we say or set the house at the origin, 0, 0, so there's our house. Okay, the first plane, okay, he's just time t. So he's going this way, okay, and he's going 200 kilometers an hour, and our distance is velocity times time. So his velocity is 200, his time is t, so his distance is 200 times t. The second plane is a little trickier. See, he's going towards the house. So, he's also 10 minutes away, going 300 kilometers an hour. So, 300 kilometers an hour, okay, times 10 minutes, so that's 10 over 60 of an hour. Okay, so 10 over 60, okay, well, that equals 50 kilometers. So, when the first plane passes the house, the second plane is 50 kilometers away. Now that distance is decreasing because he's going towards the house. So 50 minus 300 kilometers an hour times t. Because again, his distance, he's going towards the house starting 50 kilometers away. Alright, so the distance is just Pythagorean theorem. So distance squared, okay, is 200 t's squared plus 50 minus 300 t's squared. Now, one of the shortcuts we can use, at least for this question, there's only one distance. Okay, only one hypotenuse, whatever. So we kind of learned this last section. We can take the derivative of the distance squared function. I don't have to square root this, and that would make the derivative more challenging. You'll see there are spots where we'll have to do that, and they're coming up. But for right now, I can take the derivative of d squared, and it won't be a problem. Now, before I do that, I can use the power rule and the chain rule for all of these. But what I'm going to do instead is I'm going to expand these out and simplify from there. So 200 t squared is 40,000 t squared plus, well, 50 squared is 2,500. Okay, and then Remember the shortcut. 2 times that times that. Okay, so that is negative 30,000 t. And then negative 300 t squared is plus 90,000 t squared. All right, so now we just combine like terms. 40,000 and 90,000 is 130,000 t squared minus 30,000 t plus 2,500. Remember, that step isn't necessary. We can derive right from here, right from the original, and use chain rule and power rule, and I'm choosing not to. Okay, so now we go d squared, and then prime, the derivative of that. Okay, so that's going to be 260,000, t's minus 30,000. Oh, one too many. Sorry about that. There we go. All right. So remember, there's our derivative. The whole point of this is to get the derivative equal to 0. That's where we get maximums and minimums. So 26,000 t's minus 30,000. So the 30,000 comes across. Goes 260,000 t divided by 260,000. Okay, and then t equals 3/26 of an hour, which is 0.12 of an hour. Right? It said round to the nearest hundredth. So there we have it. So there's our time. Now, as far as this part goes, that's the time. Now we actually have to type that in to figure out what the distance is. Now, remember, we have a distance squared function, so to actually find the distance, we're going to have to square root, but that's okay. So we're going to substitute right back into that original equation. So d squared equals 200 times 0.12 squared plus 50 minus 300 times 0.12. Okay, and that one is all squared as well. Okay, so remember, using your calculator, either use 3/26 or use all your decimals for the 0.12. Okay, so just typing that in. 200 times 3/26 squared plus 50 minus 300 times 6 squared. Okay, and then we're going to just square root that as well. So d squared was 10,000/13. So then d equals, and I'm just going to round to the nearest hundred, 27.74 kilometers. Okay, so did we answer everything? Okay, distance between them is a minimum, so at what time? Got that. What is that distance? We got that. Round to nearest hundredth, we got that. So the minimum distance is 27.74 kilometers at 0.12 hours. All right, well, there you have that one. Number 2. Yacht A is anchored 4 kilometers off a straight shoreline. Opposite a point 9 kilometers down the coast, Yacht B is anchored 8 kilometers off the shore. A boat from Yacht A is to bring a passenger to the beach and then proceed to Yacht B to pick up another passenger. At what point along the shore should the first passenger be dropped in order to minimize the distance? All right, well, if we want to minimize the distance, we have to have a distance function. So let's put on the information that we know. We know that yacht A is anchored 4 kilometers off the shore. We know that yacht B is anchored 8 kilometers off the shore. We know that the 2 points are 9 kilometers away. So we have to make the triangles. So if we call this x, then if the whole thing is 9, then this would be 9 minus x. Okay, no big deal. So using Pythagorean theorem, the first diagonal, this guy right here, would be square root of 4 squared plus x squared. So 4 squared is 16. So 16 plus x squared. Okay, then same thing over here. So square root, so 8 squared plus 9 minus x squared. So 8 squared is 64 plus 9 minus x squared. Okay, not a very good looking 9, but I'll fix it later. Okay, sorry, we need to make that a little bigger. There we go. Okay, so remember we want to minimize the distance, so we need that distance function. So distance equals square root of 16 plus x squared plus square root of 64 plus, now let's distribute that. Okay, so then 9 squared is 81. Okay, and then the shortcut, so 2 times 9 times negative x, that's negative 18x plus x squared. Okay, and then one more simplify for this, so 16 plus x squared. Okay, so 64 and 81, that makes 145. So plus square root 145 minus 18x plus x squared. Okay, so there's our distance function. Now, before we take the derivative, I want to do one last thing. Remember the square roots. We're going to turn those into halves. Plus x squared to the 1/2 plus 145 minus 18x plus x squared again to the 1/2. Okay, so we have a little bit of work to do here, but that's all right. So we take the derivative, so d prime. So the half comes down in front. All right, so half, and then 16 plus x squared to the negative 1/2. Okay, and then chain rule times that by 2x. Okay, so that's the first one. And then the second one, the half comes down again. So 145 minus 18x plus x squared, okay, to the negative 1/2. And then we chain rule this one, so we get negative 18 plus 2x. Okay, so far so good. Now, okay, so we do some simplifying. All right, so remember how the exponent that comes down and the chain rule, they always go together. So half times 2x is just x. Okay, and then the 16 plus x squared to the negative 1/2 is just a square root on the bottom. So 16 plus x squared on the bottom. Okay, plus, okay, so then the half and the chain rule, they go together. So 1/2 times 18 is negative 9. And 1/2 times 2x is just plus x. Okay, remember, so this guy is distributing with that guy. And then, of course, the negative 1/2 is another square root on the bottom. So 145 minus 18x plus x squared. Okay. Now, to finish this up, well, there's a lot more to do, but that's okay. So we're going to set the derivative equal to 0. So 0 equals all of that. Okay, and then if 0 equals all of this, so here, let's put the 0 down here, so just save some space because I'm kind of running out. So if the 0's there, then we just move one of those over. Okay, so here, I'll erase this one. Okay, so that x is going to move over, so negative x over square root 16 plus x squared equals negative 9 plus x over square root of 145 minus 18x plus x squared. Okay, yeah. So once we have that, then we cross multiply. So we get negative x times that square root bit, 145 minus 18x plus x squared equals, okay, so then negative 9 plus x root 16 plus x squared. Okay, so far so good. Now what we're going to do is we're going to square both sides. That gets rid of the square roots. Okay, so negative x squared is just x squared. Okay, and then the square root disappears, so 145 minus 18x plus x squared equals, okay, so negative 9 plus x squared, okay, so negative 9 squared is 81. Okay, that's going to be minus 18x plus x squared. Okay, and then the square root disappears, so 16 plus x squared. Awesome. Okay, so now we have that. We have some distributive law to do. Okay, so that's going to be 145x squared minus 18x cubed plus x to the fourth. Now, distributive law is a little bit harder with this next bit, but that's okay. So when we do that, so 81 times 16, okay, so that is 1296. Okay, and then plus 81x squared. Okay, then we have negative 18 times 16, that is minus 288x. Okay, negative 18x times x squared. So we're on this one now. Okay, so that is just negative 18x squared. Okay, then we're on the x squared times 16, so that is 16x squared. And x squared times x squared is x to the fourth. Wow, I just squished that all in, but it worked. Wow, hopefully you have more room. Anyways, if you can look now, look, there's an x to the fourth on both sides of the equal sign. That means they cancel. There's also a negative 18x cubed and a negative 18x cubed on both sides. That's a cubed. Okay, so they cancel, which is really nice because then we don't have all those, and all we've got left is squares. So we'll write one more here. So I've got 145x squared equals, okay, so then we have 1296 plus, okay, so we've got 81x squared and 16x squared, so that makes 97x squared. Okay, and then minus 288x. Okay, sorry, I kind of went out of order, but that doesn't matter. We want to move all the stuff over to this side, so we get a positive x squared. So 145 minus 97x squared, so that is 48x squared. Negative 288 moving across is plus 288x. And then 1296 moving across is negative 1296 equals 0. Okay, so there is a rather large quadratic. Okay, we can go right to quadratic equation if we really want, but we should at least check to see if everything is divisible by 48. And oh, the crazy thing is, it is. So that's kind of nice. So you get 48 bracket x squared. Okay, so 288 divided by 48 works out to plus 6x, and 1296 divided by 8 is 48, pardon me, is negative 27 equals 0. Okay, well then we just factor that. So we get 48 bracket, so we get x and x, 9 and a 3. Alright, so then the 9 is positive, the 3 is negative, so then x equals negative 9 or positive 3. Now, obviously, negative 9 isn't going to work, so x is 3. Okay, so that means that we aim for a point 3 kilometers down the shore, okay, which is 6 kilometers down from A, but this x here, that's 3. Okay, well, that's cool. So, at what point along the shore we should drop the passenger 3 kilometers down the shoreline? Sorry, I don't have room to write a sentence, but that's how you would do it. Awesome. All right, guys. Number 3. A cabin is situated on an island 2 kilometers from the nearest point on the mainland. A store on the mainland where supplies are bought is 3 kilometers down the shore. If a motor boat travels at a speed of 4 kilometers an hour and the average person can walk 6 kilometers per hour, towards what point on the mainland should the boat be aimed in order to reach the store in the least time? Okay, if I want the least time, it means I have to have a time function. Okay, now you remember that distance is velocity times time, which means that time is distance divided by velocity. Okay, so that's easy enough. Let's draw a little picture here. So here's our island. Okay, here's the mainland. Okay, so we are situated 2 kilometers off the mainland, and our store is 3 kilometers downshore. So we are trying to drive somewhere along there with the boat, okay, and then walk the rest of the way. All right, so fair enough. So we're going to call this one x again. So the walking part would be 3 minus x. Okay, so then Pythagorean theorem. So 2 squared plus x squared, so that's 4 plus x squared. Okay, so that's the diagonal. That's the distance the boat travels. Okay, so now in order to do this, so time equals, okay, so the distance the boat travels, so square root of 4 plus x squared, divided by the velocity of the boat. So the velocity of the boat is 4. Awesome. Plus, now we have to do the distance that we walk. So the distance we walk is 3 minus x divided by the velocity that we walk at. So divided by 6. So there's the function that we're trying to minimize. There's the time function. So, of course, in order to do that, we take the derivative. Now, remember, here, that's just to the 1/2, right, instead of the square root. Okay, it's cheating a little bit, but it saves a line of space. Okay, so I take the derivative, so t prime, so the half comes down, so we get 1/2 4 plus x squared to the negative 1/2, okay, times the chain rule, so that's 2x, and we're still all divided by 4. Okay, no worries. Plus, okay, the derivative of 3, nothing. Derivative of negative x is just negative 1. Okay, and we're still over 6. Okay, so now we do some simplifying. Oh, we're going to make the t prime equals 0 right over here just to save some space. So look, I've got a 1/2 and a 2, so that just makes x. Okay, and then the root part, remember that's a square root on the bottom. Now there's already a 4 on the bottom, so he can just stay. Okay, and then we end up with the square root of 4 plus x squared. Okay, awesome. Plus, well, I guess it's plus negative a sixth, so really that's just minus a sixth. So minus 1/6. Okay, so look, we're going to take that negative 1/6, we're going to move it over, so positive 1/6 equals x over 4 square root of 4 plus x squared. Okay, so we cross multiply. So 4 times 1 is just 4, so that's going to be 4 root 4 plus x squared equals 6x. Okay, so far so good. Now we end up squaring both sides. Okay, so square both sides. Okay, I'll move over to up here now. Okay, so let's see, 4 squared is 16. And then the root and the squared cancel, so 16 times 4 plus x squared equals, so 16x squared, 16 squared, 16, that's my bracket, oops, so 6x, 6 squared is 36, and then x squared is just x squared. Okay, so now that the square root is gone, that 16 can distribute into that. 16 times 4 is 64, plus 16x squared equals 36x squared. So minus 16x squared minus 16x squared, so that's 20x squared equals 64. Divide by 20, divide by 20. Okay, so we can reduce that. This isn't going to work out nice, so that's all right. So 3.2 equals x squared. Okay, and then square root. So x equals a square root of 3.2, which is 1.79 kilometers. Okay, so we aim our boat to a point 1.79 kilometers down the shore. Must aim the boat 1.79 kilometers down the shore to minimize the time. There we go. Number 4. A cable television company is laying cable in an area with underground utilities. 2 subdivisions are located on opposite sides of Willow Creek, which is 100 meters wide. The company has to connect points P and Q with cable, where Q is on the north bank and 1,200 meters east of P. It costs $40 per meter to lay cable underground and $80 per meter to lay cable underwater. What is the least expensive way to lay the cable? Alright, so let's draw a quick little picture here. Oops. Okay. So here we have our river, our Willow Creek, I guess. Okay, so the creek itself is 100 meters wide. 100 meters. Q is on the north bank, so around there somewhere, call that Q. P would then be on the south bank, and Q is east of P, so right north, west, east, south. Okay, so P would be right here then. Okay, so we have to go, we have to lay cable in between the two. Now, you would think that the shortest distance is the straight line, but unfortunately the shortest distance is also all underwater. Okay, which is more expensive to lay the cable. So we're going to lay part of the cable underwater, okay, and then lay the rest underground. Okay, so easy enough. So that makes a triangle. We're going to call this side X, okay, and then if this point opposite P and Q are 1,200 meters apart, then this line would be 1,200 minus x. Okay, so that's the part of the cable we have to lay underground. All right, so we want to minimize the cost here. So the cost we have a certain distance underwater, okay, which is this distance right here, the hypotenuse of that triangle. So let's see, that's going to be square root of 100 squared plus x squared. Okay, well 100 squared is 10,000. Okay, so it's going to be 10,000 plus x squared. Okay, so that's the distance. Okay, and it costs $80 a meter for that. So $80 times square root of 10,000 plus x squared. Okay, great. So that's the cost underwater. Now we have to add on the cost for underground. Okay, and that costs $40 per meter. So $40. And we have to travel that 1,200 minus the x. Okay, so there's our cost function. So now all we have to do is take the derivative. Sounds easy enough, right? Okay, so c prime equals. Okay, so remember, I'm going to do that same little shortcut I did last time. The square root is really just a 1/2. So 1/2 times 80 is 40. Okay, so 10,000 plus x squared to the negative 1/2, right? That half went down, times it to make 40. Then we subtract the exponent by 1, and then chain rule, so 2x. Awesome. Okay, plus, okay, well, funny thing with this guy, 40 times 1,200, that's a constant. The derivative of a constant doesn't work. So really, this guy here, let's do it this way. 40, and then the derivative of 1,200 is just nothing, and the derivative of negative x is just -1. So that's how that works. So the 40 times is the derivative of the -1, and away we go. So we set the cost function, or the derivative, equal to 0. Okay, now the 40 and the 2x go together, so that makes 80x over square root of 10,000 plus x squared. Okay, then minus 40. Okay, which 40 times -1 is 40. Okay, so the 40 is going to come across, so positive 40 equals 80x over that square root bit. Okay, so of course that's going to multiply up. So 40 square root of 10,000 plus x squared equals 80x. Now I could square this right from here, but if I look closely at the numbers, if I divide this side by 40 and this side by 40, that's going to make things a lot easier. So it's 10,000 plus x squared, and then 80 divided by 40, well, that's just 2, right? So 2x. Makes it a lot smaller, so I don't have to worry about squaring such big numbers. So now we have to square both sides. So the square and the square root just cancel. 4x squared. So that's nice. So then minus x squared minus x squared. So you get 3x squared equals 10,000. Divided by 3, divided by 3. Okay, so x squared is 10,000 over 3. That doesn't work out nice. So let's just leave it as 10,000 over 3 for now. Okay, and then we square root. So x equals the square root of 10,000 over 3. Okay, and that is, well, square root of 10,000 is 100, square root of 3, so really this could be 100 over root 3. Okay, I guess we can rationalize that, root 3, so 100 root 3 over 3. Okay, still not particularly helpful, so when we type that into our calculator, it works out to 57.7 meters. Now that we know that x is 57.7 meters, that goes up here, 57.7 meters. Okay, so really what the company has to do is they have to lay cable underwater to a point 57.7 meters across Willow Creek, and then lay cable underground the rest of it. Okay, so that's going to be 1200 minus 57.7. Okay, so they're going to have to lay 1,142.26 meters underground. Okay, and really, all that's asking is what is the least expensive way. So we're going to say it just like that. We could substitute X in and figure out how much cable we have to lay under water, but it's not asking that at this point. So the company should lay cable underwater to a point 57.7 meters downshore, or downriver, I guess, or down creek, of P, and 1,142 point, I guess 3, because I use some nearest tenth, meters underground to Q. All right, and there you have it. So that's this part. It's very complex. The next two sections get a little easier, so yay. But rewind this a few times. You're probably going to need to. Challenging, but not undoable. Good work, guys. Talk to you later.